Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous session we had seen what are the different types of functions. So we'll quickly have a recap about that. So as soon as we finish the recap, we'll be moving on with the next one. So today's session will be the last session and this will be the end of the second chapter in class 11 mathematics. After this, we'll be starting with our NCERT exercises, problems. Alright, so let us have a very quick recap. So what we saw in the previous class. So in the previous class, we saw students y is equal to f of x is equal to x. Y is equal to f of x, which is equal to c. Y is equal to f of x, which is equal to a naught plus a1x plus a2x square until an x to the power of n. Y is equal to f of x by g of x, and y is equal to f of x, which is equal to mod x. So number 1, 2, 3, 4 and 5. So these are the 5 functions, okay students, which we had seen in the previous class, correct? So all the 5 things I've written it on the smart board here. Okay, so what is this function called as? Yes, what is that function called as? That is right, identity function. So this is how the identity function is represented. So just remember those, all the 5 things you have to remember. Alright, moving on to the next one. What is this function called as? Y is equal to f of x is equal to c. Yes, that is right. It is called it as a constant function. Okay, constant function. Y is equal to f of x is equal to a naught plus a1x plus a2x square until a n xn, where n is a positive integer. What is this function called as? That is correct. It is called as a polynomial function. So we'll just write pf. Okay. So y is equal to f of x by g of x. This is called as what? That is right. It is called as a rational function, where f of x and g of x both are polynomial functions and g of x is not equal to 0. Correct? So y is equal to f of x is equal to mod x. This is called as what, students? Yeah, that is right. It is called as a modulus function. Modulus function. So this is our recap. This is what we saw in the previous class. So quickly we had, with the help of the graphs. So if you have missed out the previous video, please do watch it. So I've explained each and every function with the help of the graph. So 2 more functions were left out in the previous class. So those will be covering it in today's class. Okay, so today's session will be starting with the very first one, Signum function. Okay, so like how we saw all these functions, right? Identity function is a name, constant function is a name, polynomial function is a name, rational function is a name, and a modulus function is also a name, right? In the very similar manner, we'll be seeing today the very first function is called as Signum function. So what is Signum function we'll see first, then we'll understand what is Signum function with respect to the graph. Alright. So what is Signum function? A function f such that R to R, domain to codomain or range, defined by f of x is equal to 1, f of x is equal to 0, and f of x is equal to minus 1. Students, f of x is taking 3 different values here. What is the first value? That is 1. Second value, 0, 1. What is the third value? Minus 1. So that is, what is f of x equal to? Nothing but, this is nothing but equal to y. Correct? So when is y is equal to 1? Y is equal to 1 when x is greater than 0. Whenever x is greater than 0, what is y? Y is 1. Understand? Very simple. So 0, what? 0.00000000001. If this is equal to x, correct, then what is y? So this is greater than 0, right? Y will be equal to 1. As simple as that. Correct? So when is y equal to 0? When x is equal to 0. And when is y equal to minus 1? When x is lesser than 0. So this is greater than 0, right? Lesser than 0, y will be equal to minus 1. So to remember or understand this function even more efficiently and effectively, what you have to do is, so remember like this, students. Y is equal to f of x equals mod x by x. This is how you can remember Signum function. Now see this. y is equal to f of x is equal to mod x by x. Okay, let us take x. So 3 cases we'll take here. Okay, we'll change the color. The very first one, the first case we'll take is x greater than 0. So let us consider x is equal to 17. Understood? If x is equal to 17, what is y? Y will be equal to mod of 17 divided by 17, which is equal to 17 by 17, which is equal to 1. X is greater than 0, x is equal to 17, so y will be equal to how much, students? 1. The next case we'll take, okay, we'll change the color again here. Let us take x is lesser than 0 this time, okay? X is lesser than 0, let us assume x is equal to minus 42, okay? X is equal to minus 42. What is y then, students? So y will be equal to minus 42 under the mod divided by minus 42. So that will become plus 42 in the numerator, right? But the denominator is having the minus sign, so y will be equal to what? Minus 1. Now put x is equal to 0, students. So when you put x is equal to 0, y will become equal to mod of 0 by 0. So 0 by 0 is what? So we do not know what is 0 by 0, right? It is indeterminate. So it is not defined. It's undefined or something like that. Understood? So this is called as what? This is called as a Signum function. So you can also remember this. Same thing. Y is equal to f of x is equal to 1 if x is greater than 0. Y is equal to f of x is equal to 0 if x is equal to 0. And y is equal to f of x is equal to minus 1 if x is lesser than 0. So I've done here. So case 1, okay, case 2 and case 3. So it is not defined here, but in Signum function you have to remember it is equal to 0. Okay, so moving on, next, so see this is called a Signum function. The domain of the Signum function is R, the set of real numbers, and the range is the set. So this is only the range. Either it will be minus 1 or it will be 0 or it will be plus 1. How is it plus 1 and minus 1? I have explained it here. Understood? So this is called as a Signum function. We'll see this with the graph now. Okay, so Signum function with the help of the graph. So see the students. So here you have to put, okay, a hollow circle as well as here a hollow circle. So when this is positive numbers, right? Here what is happening? All terms on all the numbers here are x is greater than 0. And all the numbers here x is lesser than 0. X is greater than 0, x is lesser than 0. So at 1, see at 1 comma 1, correct? See this point, students, not very next to 0. So let that be 0.0001. Okay, let this point be 0.000001. What is y? Y is 1 again. Understood? Signum function. Same thing is written here as well. 0, a bubble or a hollow mark there, which means 0 at x is equal to 0, y is not equal to 1. Okay, x is greater than 0, y is equal to 1. X is lesser than 0, y is equal to minus 1. So that is what is written here. So this is graph of what? Graph of a Signum function. Understood? So same thing next. See this 1 comma 1, 2 comma 1. X is equal to 2, y is equal to 1. X is equal to 1, y is equal to 1. This is going on infinitely. So if x is equal to 1000, y is equal to how much? 1. Understanding? So same thing here, students. X is equal to minus 1, y is equal to minus 1, lesser than 0, right? X lesser than 0. Here it is x greater than 0. X is equal to minus 2, y is equal to minus 1. Understanding? So this is a graph of Signum function. Okay, moving on to the next type of function, that is, the table, Signum function table. So if x is equal to minus 2, same thing, minus 1, minus 1, minus 1, 0, undefined, 1, 1, 2, 2. So here we are taking 0 for Signum function. Alright. So Signum function can also be compared with the sine one, correct? Because what is the graph for sine? 0 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. Sine function, right? Sine 0 is 0. Greater than 0 plus 1, lesser than 0 minus 1. Understood? Okay, moving on to the next function. The next function is called as the greatest integer function. So this is very simple, students. How to remember greatest integer function I'll tell you, but Okay, in the bracket you just write a left arrow mark. I'll tell you why. Okay, a left arrow mark. Now let us start with the greatest integer function. The function f such that R to R, domain to codomain or range, defined by f of x is equal to, so students, this is how you have to represent, or this is how you have to identify a function. If you see this, then you have to think what it is, a greatest integer function. This is how you have to represent the greatest integer function. Okay, x belongs to R assumes the value of the greatest integer less than or equal to x. This point is important. Less than or equal to x. Such a function is called as the greatest integer function from the definition of GIF. Okay, so this is again what? GIF, greatest integer function. We can see that GIF of x is equal to -1 for all the values where x is greater than or equal to -1 but lesser than or equal to 0. Okay, so same thing I have written for different numbers as well. We'll see the graph. Okay, so this point is, this line is important. I'll explain to students. If we see the graph, okay, we can understand this greatest integer function very properly. Okay, so moving on to the graph. So see this graph, students. So before we see this graph, we'll have a look at the table. So for example, let us take the values of x. Okay, and let us take the values of y. Okay, here what is the function? Here that also we'll write down. Y is equal to greatest integer function of x. Okay. So try to understand this table first. Okay, try to understand this table. I'll go very slowly. Once you understand this table, okay, this graph becomes very easy. You can understand it easily. Understood? So let us take the very first value. X is equal to 0. Y also will be equal to 0. This also will be equal to 0. Okay. So I think these both are same. Okay, y is equal to, these both are same. Anyways, 2 columns, 2 rows I have written. We'll go to the next one, students. Okay, we'll leave some gap here. Next we'll write +1. So here it is +1 as well. Here it is +1. So some more gaps. Here we'll write -1. This will also be -1. This will also be -1. Okay, now in between what are we going to do? Okay, we'll change the color and fill that table again. X is equal to 0.1, 0.5, 0.99, 0.999. Okay, next x values. Here we'll take 1.01, 1.9, 1.999, okay, and 1.5. Now see this, students. Okay, for minus also we'll continue further after this. X is equal to 0.1. In the previous slide what I said you, okay, so I said you to remember this left arrow mark, right? So just remember that. Okay, we'll be applying the same thing here as well. So x is equal to 0.1, sorry, x is equal to 0. So see this, at x is equal to 0, what is y? Y is also 0, right? So 0 comma 0. See here, x0, y0, 0 comma 0. Now see the next one, students. 0.1. Now what you have to do, x is equal to how much? X is equal to 0.1. Then what is y equal to? Y will be equal to greatest integer function of 0.1. Now students, see this. If any decimal numbers we write 3.987. Some random decimal number we have taken. Okay. What is this called as? This is called as characteristic. And what is this called as? This is called as mantissa. Whatever digits are after the decimal point, what are they called as? Mantissa. Whatever digits are before the decimal point, what are they called as? They are called as characteristic. So students, why I told you this is, whenever you see a function or a value within that square brackets, which means it is a greatest integer function, then you have to only consider the characteristic part. Even though if it is very, very close, so see this, 3.987 is very, very closer to 4, correct? Eliminate that, eliminate the decimal part, only take the integer part. So greatest integer, what is the integer here? If you take this, what is the integer? Integer is 3, correct? 3 is the integer. So you have to consider, so for example now, greatest integer function of 3.987 will be equal to how much? 3. It will not be equal to 4. Even though if it is very, very close to 4, okay, we are writing it as 3 only. I said you write, okay, remember this left arrow mark. So always go to the left. Okay, do not go to the right. To the right we have 4. To the left we have what? To the left we have, understanding? Okay. So now see this next. So 0.1, what is the greatest integer function of 0.1? Yes, that is right. It is equal to 0, students. Okay, it is equal to 0, not greater. Greatest integer function will always be lesser. So remember this. Greatest integer function of x will always be lesser than x. It will never be greater. Understood? So 3.987 is what? X. What is greatest integer function of that? 3. Is 3 lesser than 3.987? Yes or no? Yes, it is lesser. So that is greatest integer function. So 0.1, what should we write here? 0. Same thing here as well. 0. 0.5, it is in mid. Okay, we are not rounding it off. It should be lesser than x. So again, it will be what, students? 0. See this number, whole number. Okay, greatest integer only, no decimal. Only we are considering what? The characteristic part of the decimal number. Okay, mantissa we are eliminating. Understanding? Do not round off. Next you see 0.99, very, very close to 1. Is the answer 1? No. It should be lesser, right? So it will be 0 here as well. Same thing, 0 here as well. 1.01. X is 1.01. Greatest integer function of x should be lesser than x, right? So that should be equal to how much? 1. 1.9, 1. 1.999, 1. 1.5, 1. Are you understanding this? Yes. Any difficulties in this? Okay, please do let us know by commenting in the comment section once. Alright. So remember this part, students. Always consider the characteristic part. Okay, we'll change the color here. Points to be remembered. Point number 1. Always consider the characteristic part. Okay, point number 2. Greatest integer function is always lesser than whatever value we have taken for x. Okay, point number 3 is, I think that is it. Okay, it should be lesser. Only 2 points you have to remember here. So that is nothing but what? Greatest integer function. So now we'll see the graph here. Okay, at 0, 0. See the students. At x is equal to, okay, I think we have to enhance that image. Anyways, fine, no problem. So this is 0, 0, right? So let us take this point as what? 0.1. So this red line, that line is what, students? 0.1. What is the value of y? The value of y is 0 only. So until here you come. Until this point. Okay, that is what? 0.99. What is the value of y? It is still at 0 only. Once you reach 1, what is this point, students? See this, x is equal to 1. At x is equal to 1, what is y, students? Y is equal to 1. Next you come here at 1.5. What is y? Y is still 1. Come at this point. At 1.99, what is y? Y is still 1 only. Okay, so this point is 2. So we are putting a hollow circle, which means we are not including that. So in the previous slide, you can understand this. See, x is lesser than 1. If it is equal to 1 is not given here. Only lesser than 1. Understanding? So the greatest integer function will something come like this. Okay, I'll explain it here once again. So this is 0, 0. This is 0.1, 0.2, okay, 0.5, and this is 1. So this is again 1.1, 1.2, 1.5. This is 2. Okay, here we'll write 1, 2, and 3. This side also will take minus 0.1, minus 0.2, minus 1. Okay, there are few more points, I'm not mentioning it. Now let us see this graph, students. Okay, see this one. At x is equal to 0, y is equal to 0. At x is equal to 0.1, y is equal to 0 only. At x is equal to 0.2, y is equal to 0 only. X is equal to 0.5, y is equal to 0 only still. Y is still equal to 0. See this point, students, now. This point you come. X is equal to 0.99999. What is y? Y is still equal to 0. Greatest integer function. At x is equal to 1, y is equal to 1. So we'll put a hollow circle there. X is equal to 1.1. So here, so this point is 1.1, right? See here. Okay, here it is. At x is equal to 1.1, what is y? Y is equal to 1. X is equal to 1.5, what is y? Y is still equal to 1. At x is equal to 2, y will be equal to 2, like this. So if you keep on plotting the graph like this, okay, finally you will be getting something like this. So we'll just erase this here, okay. See, your final graph of greatest integer function will something look like this. Okay, try plotting the graph. Okay, any doubts in plotting the graph as well, you can always let us know by commenting in the comment section. So if you comment your doubts, students, I'll be taking a special session on that, explaining all your doubts. Okay, so this is the end of types of functions. So what we saw today, we saw greatest integer function as well as the previous to this one, Signum function. Understood? So totally we have studied 7 different types of functions. Okay, we'll have a quick summary on that as well. So before we do that, okay, we'll go to the next topic, which is called as algebra of functions. Okay, so we'll consider the pen here, algebra of functions. So what is algebra of functions, students? Elementary operations on functions. That is nothing but what? Plus, minus, multiplication and division. So for example, f of x such that x to r, domain to range, where x is a subset of r, and also we'll define g of x such that x to r, and again x is a subset of r, and x belongs to x. Understanding? Okay, you'll understand it. See this. So let us assume one function f of x is equal to x square plus 1. Okay, and g of x is equal to 3x. Now, how do we add this function? F plus g of x is given by x. Okay, such that we'll write here. Okay, no arrow mark. X to r, where x is a subset of r. What is r, students? R is a set of real numbers. Correct? What is x? X is a subset of r. See, if we're inputting x, domain is x, and output we are getting it as real numbers, which means what? The input is also real, right? So that is why we are writing x is a subset of r. And f of x is such that x to r, which implies that x is a subset of r. Understanding? Okay, so substitute some values here. Put x is equal to 9. 9 square, 81. 81 plus 2. 81 plus 1, 82. What is x? 9. 9 belongs to r. 82 is also belonging to r, right? Correct. So, assign some values, you'll understand it very quickly. Okay. So g of x such that x to r, such that x is a subset of r, and x is belonging to x here. So we have taken one example, x square plus 1, 3x. Now if you want to add the functions, f plus g of x is written as f of x plus g of x, which is given by x square plus 3x plus 1. Okay, this is the right answer. Understanding? So this is addition of functions. Similarly, subtraction of functions, f minus g of x is given by f of x minus g of x, which is equal to, what is f of x? X square plus 1. Square plus 1 minus g of x, 3x. Subtraction of functions. Scalar multiplication of functions, students. So for example, okay, we'll change the color here again. Let us take, there is a scalar or some magnitude. Let us take alpha. Okay, alpha f of x means a scalar is multiplied with the function, then that is written as alpha into f of x. Scalar multiplication with the function. Understanding? Next. So we finished addition. Where is addition? Yeah, this is addition. Okay, this is subtraction. Scalar multiplication with the function. Apart from this, f dot g of x, multiplication of functions. Okay, multiplication of functions. How do we write this? F of x dot g of x. Division of functions, f by g of x, which is equal to f of x by g of x, which is equal to, students, with respect to the example, what can we write? Okay, we're changing the color here again. With respect to the example, we can write f of x is nothing but x square plus 1 and g of x is nothing but 3x. So here f of x into g of x, what is f of x? X square plus 1. And what is g of x? That is nothing but 3x, which is equal to 3x cube plus 3x. Multiplication of functions, division of functions. Let alpha be equal to, let us take 7. Like alpha be equal to 7. So it will become 7 into f of x. So what is f of x here? X square plus 1. X square plus 1, which is equal to 7x square plus 1. Understanding? So this is algebra of functions. So what and all we saw in algebra of functions? Addition of function here, subtraction of function. Apart from that, scalar multiplication with the function, multiplication of functions, as well as divisions of functions. So x is belonging to, small x is belonging to capital X and x is a subset of R. To understand these things, what we saw, we assumed some examples or we assumed some numbers and we got it. I think this is very messed up. Okay, so you can pause the video. Okay, if you want, you can just rewind it back and make a very clean notes of it. Understanding, students. So maintain the notes. It will be also helpful in your boards as well as in your competitive examinations. Alright, so this is all about algebra of functions. So based upon the algebra of functions only, I have taken one example here. So this is x square, by the way, okay? X to the power of 2. So here we'll see if f of x is equal to x square and g of x is equal to 2x plus 1 be two real functions. Okay, find the elementary operations of the functions, which means multiplication, addition. So let's start with the first one. F of x plus g of x, addition of functions, it will be x square plus 2x plus 1. Second, next elementary operation, subtraction, f of x minus g of x, x square minus 2x minus 1. Third elementary function, multiplication, f of x dot g of x, multiplying two functions. F of x is nothing but x square of 2x plus 1, which is equal to 2x cube plus x square. Okay, the next one, division of functions, f of x by g of x. So this will be equal to what, students? F of x is nothing but x square divided by g of x is nothing but 2x plus 1. Now this can be 0, right? If the denominator is 0, we call it as what? An indeterminate form. So x belongs to set of real numbers except minus 1 by 2. This is the point to be written. In the place of x, you write minus 1 by 2. What will happen? 2 and 2 will get cancelled. Minus 1 plus 1 is 0. So this function will be not defined. So just to avoid that, what we are doing, x belongs to the set of real numbers except minus 1 by 2. And this is your right answer. Multiplication, division, subtraction and addition. Understood? So this is all about algebra of functions. We have done one example as well. Okay, in the next class, we'll be starting with the NCERT problems. So until then, take care, wear mask, maintain social distance, and also sanitize your hands. Thank you, students. I'll be seeing you very soon.